Okay, hi everybody. Привет, Novosibirsk. I hope that was not too terrible. Thank you. First time I've been clapped for that. So my name is Ramon, and for the next 40 minutes, I'm going to talk to you about why you might not need classes in JavaScript. But before we get into the topic, let me tell you a little bit about me. So I'm a front-end web developer from Madrid, Spain. I work at a small startup called Undefined Labs, in which we build developer tools to help teams ship better code faster. We are currently working on a tool called Scope that is focused on testing visibility and is especially useful in microservices environments. And I've seen some talks related to that in this conference, so that might be something that interests you. So if you want to learn more about that, you can go to scope.dev and request early access. Besides that, I work with JavaScript and React, but and I really like those technologies, but what I really like above all is the web as a platform. I love its promise of an open medium accessible to all. And I really like also the community, the web community around it. And that's partly why I like to go to conferences like this one, to give talks. I also volunteer at a lab, which is coding bootcamp for women in Madrid. So you probably can already tell that I care quite a bit about diversity and inclusion in our community. So let me take just a second to say that one of the things that I would really like to see as part of this inclusion effort is conferences stepping up their game when it comes to these issues. So things like having an enforceable code of conduct so that everybody can feel safe, or making an active effort to feature more diverse speaker lineups. And some conferences already do this, and that's great, but I would really like it to become the norm rather than the exception. And you as attendees have actually the power to change it, so because you can demand these things from the conferences you would like to attend. So let's see if we can do better in the future. If you want to reach out to me later, that's my Twitter account. My DMs are open, so you can just write to me, whatever you want, questions, feedback, they would be greatly appreciated. And with all that being said, let's get started. So what are we going to discuss today? First, we're going to see why we got classes introduced into the JavaScript language, to give you a little bit of context and history. Then we'll go on to check the most common issues and pitfalls that you might bump into when working with classes. Later, we'll see some alternative patterns to using classes in JavaScript. And finally, we'll review some recent case studies of popular JavaScript frameworks moving away from classes. So you can see that it's not only me talking here, but that there's actually community moving around this issue. So why did we get classes in the first place? Classes were introduced into the language over 4 years ago. They were part of the 6th edition of the language, known as ECMAScript 2015, as you probably know. And when we think about classes, we tend to think about object-oriented programming, right? But it turns out that object-oriented programming, JavaScript already had a mechanism for object orientation right from the very beginning. It is the prototype. So if we already had prototypes, then why did we get classes again? Let's look at an example to understand a little bit better. Here we can see a counter class implemented with prototypes on the left and classes on the right. And we're going to be using this example along the talk, so you can take a good look at it, but it's not too complicated. It just gets an initial value in the constructor, and then it has a method to increment the counter and another one to reset the value. It's simple. So in this case, the class on the right, it looks a little bit cleaner, but I'd say it's not such a dramatic difference. However, when you try to do inheritance with prototypes, things get much uglier and messy. Here's a step counter that inherits from the counter that we saw before. And when doing this with prototypes, well, as you can see on the left, we need to do some weird things, whereas with classes on the right, we just need to use the extends keyword and call super on the constructor, and we are done. The syntax is much nicer. So based on what we just saw, we could say that we got classes in JavaScript as an improvement over prototypes, at least in terms of syntax, as we've seen. But I would argue that there's probably a more important reason, and it's that classes are familiar for new people coming to the language from other languages. I don't know if you've heard, but JavaScript has become quite popular in the last few years. So introducing something like classes, that is a concept already familiar to people and that already existed in a lot of other languages, seemed like a good idea. So, classes don't seem so bad, right? There are legitimate practical reasons to have them in the language. They are better than prototypes, at least in terms of syntax. So what's the problem then? Well, there are actually a few problems, so let's get over them. The first and most important one for me is that classes in JavaScript create false expectations. We just said that the reason to add classes to JavaScript was because they are a familiar concept. But the thing is that classes, the way they work in JavaScript, it's not the same as in other languages. So we are using the class word for something that doesn't quite behave as you would expect from a class, which is a little bit weird, a little bit disconcerting. Let's see an example of this. Here we have our counter class again. So let's say we instantiate it with 0 as the initial value, then we call the increment method, and then we log the value, and okay, it's 1. Everything's working fine. But what happens if I now do this? First notice that, as you might know, JavaScript classes are basically syntactic sugar over prototypes. So you can see here that I can actually access the underlying prototype, which we could call a pretty leaky abstraction, at least. But besides that, the thing is that the prototype is a living object, it's an instance on itself. So even though it's been changed now and that we instantiated a counter before, if I now call the increment method, it doesn't go up to 2, it goes up to 0 because the prototype was modified, and it's a live thing. And that's the core of the issue, that typically a class defines a type that can be later instantiated in runtime, whereas a prototype in JavaScript is actually a living object instance itself that is then referenced by other objects. And that's the key word, living. Prototypes and instances themselves. So you can modify them, and the changes will affect previously instantiated objects. Unlike classes, definitions in prototypes are not statically copied at declaration time. And again, since classes are syntactic sugar over prototypes, they behave this way as well. And that can be really confusing for someone used to classes in languages like Java, for example. Also notice that in the example from before, I could access the value property from the outside. If we have a counter object with its own increment method, we might want the value to be private. And here's another issue with classes. They lack a lot of features that we have in other languages. We don't have private members. We don't have static members. We don't have decorators. There are proposals for all these things, but they're not part of the standard yet. They will likely take some time to land still, because they are tricky to implement on top of prototypes. If you use TypeScript, you get some of these things. You get public, protected, private fields and methods. You get read-only properties, even abstract classes. But that's in TypeScript, not in the JavaScript standard. And actually, another problem on top of all this is that TypeScript implements these things in a very different way to the way they are being implemented for ECMAScript. So that's going to be an issue at some point. They're gonna need to converge. And honestly, I'm not even sure we want or need some of these things. Take static methods, for example. They make sense in languages like Java, where everything needs to be a class. But in JavaScript, you can define a standalone function and just use it from wherever you need, including from inside a class. So there are, for sure, some use cases, but there are not as many as you might think. And we're introducing all this complexity into the standard to implement all these things. Whereas in most cases, you could do it some other ways, not that necessary. And then besides this is the context binding problem. Handling this keyword in JavaScript is confusing and very error prone. And these kinds of problems with context show up with asynchronous code, which is basically everyday code in the browser, so you are bumping into this all the time. Let's say we have now this button class that just gets a click handler. We are now instantiating a counter, the same counter we were using before. And we use its increment method as the click handler. We are passing it to the button. So the idea here is that whenever you click on the button, the counter will get incremented. That's easy to get. Well, what happens is that the counter is not actually incremented. And if we look at the button, we see that it has a value property that is not a number. That's weird. Some of you might already know what is happening, but the problem is that the increment method uses the this keyword internally to access the value, the property value, and increment it. But and we're passing it as the click handler to the button in this line. But the this keyword in this line is actually the button, not the counter. So button.value is undefined, undefined plus 1, not a number. That's why this happens. So we need to bind the inc method to the counter instance. We can do it like this in every call. This looks like we are going to forget at some point, so okay. This is our problem. We have to do it every time. And we can do it either with a bind method or with an arrow function. But it's better to move it to the constructor of the counter class. That way, we don't forget. The syntax is a little bit weird, though, but it doesn't matter. We can use the class field arrow function proposal and write it in this way. The syntax is nicer. It does exactly the same. Great. We've solved our problem, right? Well, the problem, again, is no matter which way you do the binding, if we now look at the prototype of the counter, we'll see that we get the constructor and the reset method, but the increment method is not actually there. And this is because the increment method is no longer a class method. It's an instance property, and we've just seen this. We've just seen this before. Here, what we're doing is we are getting the instance, adding an increment property, and then assigning it to the increment method in the class binded. So the bind method creates a new function effectively. So yeah, it's not part of the class anymore. We are basically adding to every new instance this inc thing in runtime when it's constructed. So again, classes are supposed to be a blueprint, and instances are supposed to reference the methods in the class. But here we are creating a new function for every instance, which is, again, not what you would expect in a class from other languages. And this also can have some performance implications, but I would say that those are very, very minor compared to the other problems that this creates. Finally, on top of all this, classes are harder to deal with for tools. They don't minify very well, which results in larger bundle sizes. Method names, for example, cannot be safely minified. Most minifiers just leave them as they are, untouched. Also, automatic death code removal of class methods is not easy. It's much easier to do that with functions too. It's easier to remove unused functions than class methods. And there also, classes are not very friendly to some advanced techniques either, like ahead of time compilation. They make it harder, and hot reloading. It can be unreliable when using classes. Okay, so we've seen why we got classes. We've seen the issues we might find with them. So let's say we want to avoid them, at least in some cases, because of the problems we've seen. But we surely don't want to go to prototypes, right? Because classes are just syntax with sugar on top of them, and prototypes is just same problem, but with a weirder syntax. So what's left? Well, what's left are just functions. In JavaScript, we can take advantage of core fundamental features of the language, like closures, to do similar things to what we do with classes, but only with functions and with a little bit of a different mindset, but it's mostly the same. And we can emulate object-oriented programming features typically implemented with classes like inheritance, encapsulation, polymorphism. We can also do implement some design patterns like singletons or factories. We are going to see examples of all of this. So let's take a look at how we can leverage closures to do these things. First of all, closures help with encapsulation, one of the issues we had, that we couldn't have private members. So going back to our counter example, we now have a CreateCounter function. It's a function that returns an object, an instance. And first we can see how we don't need to save the initial value anywhere in the instance. So we are just getting as a parameter, and then in our reset method, we are using it right away. And due to the way closures work, this initial value is binded to the instance return, and you don't need to do anything special. And for the same reason, the counter value, it's now private. We are declaring this constant here, and in order to read it, we need to return a method in the object that we are returning to get the value. But if we didn't have this get value function, we couldn't actually access the value from the outside. So we are effectively getting private members with this. I'm sure one concern that you might have is that unlike classes, there's no reference here. We are creating a new object all the time. But I would say that's not too important. First, because they're not such a problem. Like, they're very cheap. You can have a lot of, in order to reach a point in which having a lot of instances is a problem, you really have to have a huge app or a very specific use case. And also with classes, we still need to bind some methods. So we are actually creating new functions, not for all the methods, but for the ones that are binded, we are doing the same thing. We are creating new functions. So it's not such a problem. And in return, we get private members, as we've seen, and we also avoid issues with the this keyword, because we're not using it. So if we're not using it, there's no issue to be had. This is the button example that we saw before. Now we are using a CreateButton function, same idea, basically the same code. Everything works without doing anything, without needing to bind or without needing to do any other magic. And this might look like a very simple example, like something that you could say that it's not so useful, but it's actually a pattern that is actually relevant and useful in real life. Let's say, for example, we have something like this, a class to access some API. And this API needs a token for every request. So what we do is, we don't want to have a bunch of functions and be passing the token all the time. So we write something like this, a movie API class that gets the token in the constructor, saves it on the instance, and then when we call this add favorite method, for example, we can access the token that was saved when the constructor was called. And we use it like that. New movie API, we pass the token, and then we can call the methods right away. Well, we can do this, applying the idea we just saw, we can do the same thing with a function, create movie API. Same idea, it gets the token, we don't need to save anywhere, because again, due to the way closures works, we just return an object, the add favorite object, and we can access the token right away. And the way we use it is really similar. Instead of new movie API, we just call create movie API with a token. So it's almost the same. But we don't have this problem of having to bind things and remembering it. Object composition is another powerful concept that we can use. It helps us implement equivalent patterns to inheritance and polymorphism in a different way, but still the concept is the same. So here we have a CreateCounter factory function. It's almost like the CreateCounter that we saw before. The only difference is that instead of the increment method, it now has a setValue method. So the idea is that this will serve as a base class, so to speak, that we are going to use to build other counters on top, the ones that we are actually going to use. This could be a private function living in some module. So now based on that, we can recreate the step counter like this. We call the CreateBaseCounter, and we basically get all the methods that it has, all the properties, but setValue. Because we don't actually want to expose setValue. What we do is we use it on our increment method to set the value of the counter, but it stays private to the step counter. So we are basically returning the methods that we saw before. We're returning the reset, and we are returning the get value in this rest constant that we see there, and then we are adding to the instance the increment method, which uses set value internally, but the set value itself is not returned. And like this, we can do the create counter that we had before as well. Same idea, only we use one for the step counter, and we could also combine them in many different ways. Like we could define the counter based on the step counter, but with one as an argument. You can mix and match all you want. And we have here a similar thing to what we had before. We can even overwrite methods. If CreateBaseCounter, for example, already had an increment method, the way objects work in JavaScript and the way the spread operator works, even in this rest counter, we have the increment method. We are defining it again below, so it would be overwritten. So you can do that as well. And then function composition and higher order functions are some other resources that we have in our functions toolbox. And we can use them to implement patterns similar to decorators or mixins. Let's look at this. This is a higher order function, which is just a function that returns another function. And it's called with login, because what it does is it logs to the console the arguments that the original method was called with, and then calls the original method. So to use it, we just get the function that we want to decorate, pass it to the with login function, and we get back our decorated function. It's a little bit more verbose or more explicit than using the add syntax for decorators in classes, but it works. Finally, in modern JavaScript, we also have modules, and they provide encapsulation again, and can also help implement some design patterns thanks to that. For example, a singleton. We were actually talking right before this talk with someone that was asking about how we could do a singleton without classes. Well, if you use JavaScript modules, it's as simple as this. There's an 11-line module. The only thing that it exports is the create singleton counter function. And what it does is we have an instance constant that is private to the module. Notice that it is not exported, so it cannot be accessed from the outside. And what we do is when the create singleton counter function is called, if we didn't have an instance, we create one and we save it in this variable. And if we already had the instance, we just return it. So this is an easy way to have a singleton using modules. You can do singletons with classes in JavaScript, but if you want to do them covering all the edge cases, it can get a little bit tricky. You can look up for the code online, and there are some rough edges. So with this, it's relatively easy to do. It's just straightforward. Okay, so as I was saying in the beginning. Is this just something that I'm obsessed about with for some reason? Or is there movement happening in the community around these issues with classes? Well, the thing is that there is some movement, and there are examples of popular JavaScript frameworks that are moving away from classes. So that's what we're going to see now. The most popular one probably is React with its hooks. React already had a class-based API to define components for the web. And one of the problems with that was that they had a function-based API and a class-based API to define components. So whenever you wanted to add state to a component or to add side effects, you had to rewrite your component from a function to a class, which was a pain in the ass. So with hooks, what they did is basically provide you with functions that encapsulate this state, and you can use them right from your function component, so you don't need to write classes anymore. This would be a simple example, a counter again. We are calling the useState hook, passing the initial value, and what this gives us is the value and a setter. And then we use it in our code. And notice how, for example, in the on-click of the button, we are using SetCounter right away, and we are not doing any binding. If this were written as a class with React, we had to remember that the increment method needs to be binded so everything works. But here, because everything is inside the function, it's a single closure, you can reference everything without these problems with the this keyword. And another interesting case, and I think this is actually more interesting, is Vue. Vue didn't have a class-based API to define classes, and they wrote a proposal for it because the community thought it was a good idea. We had the React example. So they came up with a proposal, and at some point they decided to drop it because they found some problems that at some point they thought that the problems were more than the advantages, and they decided to drop it actually in favor of something that they call the Vue Composition API that is heavily inspired by React hooks, and it's a really similar idea. This would be an example of the same counter with Vue. And you can see there that there's a setup method, and we have this Vue reactive thing, which would be the similar thing to useState that returns the state, and then we have the increment method to increment it, and then we use it on our template. So this is similar. Again, no need for a class. And the interesting thing, especially in the case of Vue that didn't have a class-based API, had a proposal for it, and then finally decided to drop it. These two frameworks decided to move away from classes because they found out that they had some issues, some of which we've already talked about, and some of which we haven't talked about yet, and that's what I want to talk about now. So first, in the case of Vue in particular, they realized that classes mix concerns. If you have, for example, you have a component that needs to attach an event listener to some DOM element, and then on a mount, it needs to be removed. The problem we have here now is that in frameworks like React with classes, you have this component in mount method, and you need to add the event listener there. And then you have a component with a mount method, and you need to add the remove listener call there. So the problem is that we are not grouping code by feature, but by at which time in the component lifecycle things happen, which is not really natural. And this case is simple because we only have an event listener, but we had like 3 different event listeners, and then a network request, and then some other thing. We'd have like 3 different pieces of logic scattered all around the component, and it can be difficult to follow. And it happens a lot. You will probably at some point decide that you don't need the event listener anymore, so you will remove the add event listener, but you will forget to remove the remove event listener because it's not everything is the logic is not encapsulated. It's spread around the component. So the good thing with things like Hook or the Vue Composition API is that we can group our code by feature And since there are not methods, since there are not some special methods that need to be used in a class, there is just functions. We can actually extract that code into a function outside of the component. So in the example of view, we could take everything that is in the setup, in the setup property, because it's just functions and constants, and move it to a function outside and call it useCounter, for example. And if we had in this component some other functionality, we could extract it to some other function, give it our name, and we would call it from the setup. With the additional benefit that we can now reuse that between components. We can have that thing in some other file, and we can import it from different components. So we are really encapsulating state and side effects that pertain to the same feature in the same function, which is really nice. Actually related to this, classes lead to convoluted patterns, because if we want to reuse, if in the example before, if we wanted to have this this component that adds an event listener and then removes an event listener, the thing is that we need to, it's a component, so we need to render something. But the problem is that we don't really want to render anything. We just need to encapsulate that logic. So in the end, we have patterns like higher order components, mixins, render props. Very complicated. I mean, they're really useful, but the first time you look at them, they're like hard to grasp, and they're complicated and they're cumbersome. Whereas with things like, whereas with APIs based on functions like these two we've seen, we don't have that problem. We just define the function somewhere else, and we just call them. They work much better. And again, this leads to the next point. Well, also something I forgot is that patterns like that, they're not only more difficult to follow, they are also had some problems, like if you use a higher order component and you are injecting props into a component from different ones, the sources are unclear, because now you don't know which prop is coming from which mixin or from which higher order component, and it could also happen that the names clash. So that's an actual problem. And related to this, because function-based APIs leads to less convoluted patterns, it also means that they are more type-friendly. Since we're using mostly plain variables and functions, they are easier to type with any static type system like TypeScript or Flow. And sometimes you don't even have to, because type inference works way better when you have that. These convoluted patterns we were talking about before, they are harder to type, because you will have to you'll have to use some special syntax from TypeScript or Flow to say, okay, these props are coming from this higher order component, and then I need to define that this accepts like the props coming from here, and then it's some props. It's if you've ever had to do that, you know it's quite a mess. So that's another benefit of these approaches. And this is all these three things, which I would say are huge, they are only based on component frameworks. This is actually on top of all the benefits that we previously mentioned, like the bundle size. The fact that we're using hooks and we are not using classes means everything is a function. So the bundle size is actually smaller, because they minify better. So that's an extra benefit that we get from it. Okay, so that was a lot, right? Let's do a quick recap of the main points of the talk, so at least you can remember something tomorrow. First thing and most important one, and I already mentioned it before, adjust your expectations when working with classes. I'm not saying you should never use classes. There are some valid use cases for classes in JavaScript, but you need to know that they do not work as in other languages. So if you don't know about prototypes, you should probably learn a little bit about them. And this is an especially important issue when you are onboarding people coming from the backend, for example, that they now need to work on this React web app or this Vue web app or whatever it is. And they think that these classes are, oh, this is great, because they're familiar. They're just like Java classes, the ones I've been using until now. And then they bump into these things like, but why is this not working? And it's so hard to explain that. I know, oh no, you actually need to do this arrow function craziness, and they're like, why? And explaining that is really hard because it's like a rabbit hole, because you really need to get down to the prototypes to explain all that. It's very confusing. So even if you use them, you really need to know what you're doing. Then, of course, watch out for issues with context and the this keyword. So remember to bind your methods with dealing with asynchronous code. I know I have to do it, and I forget all the time. So that says something about the quality of the feature. If I know and I still forget every time. And also look out for encapsulation issues. We saw before that the fact that we don't have private members. Use Babel to if you want that feature, or maybe use something like TypeScript. And finally, unless there are real performance concerns, which is rare in apps, but it could be, you have a very particular use case where you have tons of instances, but like a lot of them, or if your framework imposes you using classes, which is not so common anymore, as we've seen. But unless one of those things happens, consider using functions, closures, modules, object composition, function composition. They're all powerful, and they feel very natural to the language. And the thing is that closures, in particular, are in fact so fundamental to the JavaScript language that you are going to have to learn them anyway, because you are going to bump into that. So you might as well take full advantage of them, and at least sometimes try to consider just using functions and implement some of the patterns that we've seen. And that's all for me. Thank you.